Security in a Besu network is layered. Nodes, APIs, accounts, validator keys, smart contracts, and infrastructure all need protection. In this module, we'll focus on practical controls for production deployments, vaults, HSMs, key rotation, recovery, and monitoring. You've already built the foundation: Besu basics, enterprise network design, application development, and governance requirements. Now we add the protection layer, so the systems you design can withstand real operational and compliance risks. Besu security is an architecture, not a single feature. TLS, key protection, and permissioning all matter, but none is enough on its own. Design layers around smart contracts, APIs, nodes, keys, infrastructure, and operations, assuming any one layer can fail. Validators, RPC endpoints, and signing keys deserve special treatment because compromise there can change network behavior. Separate responsibilities so no single role can silently introduce risk, and plan for the full lifecycle: prevent, detect, respond, and recover. A threat model gives structure to security decisions. Instead of asking, "Is this network secure?" ask three sharper questions: what assets matter, who could attack them, and what damage would result. In Besu, high-value assets include validator keys, RPC access, smart contract execution, permissioning rules, and node infrastructure. Each threat should map to controls, such as HSMs, allow lists, contract review, and node permissioning. That turns vague risk into concrete engineering work. Validator security starts with separation. Keep validator nodes off public networks and restrict administration to a trusted management path. Store signing keys in hardened systems with strong access controls and audit trails. Monitoring closes the loop. Watch for missed blocks, unexpected signing, or behavior that suggests compromise. If something goes wrong, teams need a governance-approved emergency process to rotate keys, replace validators, or remove them before consensus integrity is harmed. Not all secrets in a Besu environment have the same job or the same blast radius. Validator signing keys affect consensus, so they need strong isolation and strict operational controls. Account private keys authorize transactions, which makes theft immediately financial or administrative. Node identity keys establish peer trust, so compromise can disrupt networking or impersonate infrastructure. Application secrets cover APIs, databases, and integrations. Treat each category separately, with protection matched to its purpose and failure mode. Private keys become dangerous when they are copied into code, files, images, or laptops. A safer pattern is separation. Besu and related applications request access or signing from a vault, cloud KMS, or HSM without broadly exposing raw keys. These systems enforce policy, least privilege, auditing, and often short-lived credentials. Use HSMs when signing keys require the strongest protection and tamper-resistant hardware assurance. Treat keys as living assets, not configuration files you set once and forget. Generate them in a trusted environment with strong entropy and limited access. Then store and use them under monitoring, so unusual activity can trigger rotation. Backups must be encrypted, tested, and governed by approval. If a key is exposed, revoke it, replace it, and restore access through a documented recovery path that operators have practiced before an incident. Besu JSON RPC endpoints are powerful because they let clients query and control node behavior. In production, treat them like privileged admin interfaces. Bind them to localhost or private subnets by default, and enable only the namespaces your application actually needs. Keep admin and debug methods away from untrusted networks. Add allow lists, authentication, reverse proxies, and segmentation. Then monitor call volume and method patterns so suspicious access is detected early. Network security starts by assuming every interface is reachable unless you deliberately restrict it. Firewalls and security groups define which sources can reach RPC, peer-to-peer, admin, and monitoring services. TLS protects traffic that is allowed through, especially RPC and management calls. Allow lists add another gate by accepting only approved nodes, accounts, or peers. The goal is segmentation. Public access, validator traffic, administration, and observability each follow separate auditable paths. RPC access should sit behind enterprise controls, not directly in front of users. A request should first pass through an API gateway or reverse proxy, where identity is checked against SSO, OAuth, OIDC, or LDAP. Rate limits help absorb abuse and reduce denial of service risk. Important actions are logged, including successful calls, admin access, failed authentication, and policy violations. Besu receives only requests that have passed these controls, while rejected traffic is stopped earlier. Treat every smart contract as production security code. Before deployment, use peer review to challenge the business logic, permissions, upgrade paths, and failure modes. Prove behavior with automated unit, integration, and scenario tests. Good tests include the unhappy paths, unauthorized callers, invalid inputs, boundary values, expected reverts, event emissions, and malicious transaction sequences. The rule is simple. If the contract cannot pass these gates, it is not ready for a Besu production network. Security checks should be release gates, not optional cleanup. Start with static analysis to catch known patterns like reentrancy, unchecked calls, and access control mistakes. Then use unit, fuzz, and property-based tests to explore paths humans may miss. For critical contracts, formal verification can prove key invariants. Only after audit sign-off, coverage thresholds, and governance approval should deployment proceed. A failed gate stops the release until the issue is fixed. Now imagine an exposed RPC endpoint starts receiving suspicious transaction attempts. The response should already be rehearsed. First, detect and preserve evidence, logs, API traces, node state, and backups. Then contain the blast radius by isolating systems, rotating keys, and disabling risky access. If validators or permissions are affected, governance must authorize emergency changes quickly. After recovery, run a post-incident review so the playbook, monitoring, and controls improve before the next event. The key message is simple. Besu security is lifecycle work. Start with threat modeling. Protect validator and account keys. Harden APIs and networks. Verify smart contracts, and prepare incident response. These foundations make monitoring, observability, and future AI-enabled blockchain operations safer and more trustworthy.